A mathematician predicted 3 World Cup winners in a row. Was he a genius or just lucky? And how can the answer to this question help you and me to make better decisions? A German mathematician and economist, Johann Clement, successfully predicted 3 World Cup winners in a row. He predicted correctly that in 2014 the winner would be Germany, in 2018 France, and in 2022 Argentina. He later explained that he created an elaborate model that considers different factors such as the size of the country, the population, the economic figures, and so on. All in all, this model helped him to predict the winner of the World Cup. But how difficult really it is to make such correct predictions? Until 2026, there were 32 teams in the World Cup. So assuming that we select a winner at random, we make a random guess, the probability that we do it correctly is 1 over 32, which is about 3%. But if we were to predict 3 World Cup winners in a row, then the probability of success is 1 over 32 times 1 over 32 times 1 over 32, which is 1 over 32,768. That is less than 0.003%. Predicting those 3 winners randomly is exceptionally rare. That sounds like the achievement of Professor Clement is something unbelievably amazing. But that is not exactly how it was. You see, it's not like we asked Professor Clement about his predictions and then we observed the outcomes in the consecutive World Cups. That would be really something. But the real story was different. I have run Google search on the Professor Johann Clement, adding a filter to show me only articles and pages before the Qatar 2022 World Cup. As you can see, there is no mention of his predictions by then. Until his third successful prediction in 2022, he was not really known for making them. What does it really mean? Well, it means that we have looked at his predictions only after they came true. And that detail is actually very significant. Let's think now of a different problem. What is the probability that at least one out of many people makes a correct prediction for those 3 World Cups? Well, the formula is given here, and it's basically the inverse of the probability of the opposite outcome, which is that nobody finds the correct result. And after doing those boring calculations, it turns out that for 1,000 people, the probability that at least one person finds all the 3 winners correctly is about 3%. But here is where it gets interesting. If we consider 10,000 people randomly predicting the World Cup winners, there is already 26% chance that at least one of them will get that right. With 50,000 people, this probability goes up as high as 78%. And with 100,000 people, we get as high as 95% chance of getting at least one person predicting the results correctly. That means that with a large enough crowd, we are almost guaranteed to find somebody who predicts those 3 World Cup winners correctly. We can even go further. With a large enough crowd, we can even find somebody who makes 4 predictions correctly. Consider another example. Imagine 10,000 people rolling the dice 4 times. Probability that one person will get all ones is very low. It's actually 1 over 1,296. But with 10,000 people, the probability that at least one of them will get 1111 is almost 100%. It is almost certain that somebody will get such a sequence. Would you call this person a dice expert? Somebody who can predict or control rolling of a dice? No. It's just a simple fact of statistics and probability that with a large number of repetitions of experiments, you will get the result on average. This phenomenon has a name. In statistics, it is called the selection bias and is surprisingly common in many different areas of life, not just sports predictions. Selection bias is simply this: you only see the successful predictors, not those who failed. In his excellent book, Thinking Fast and Slow, Daniel Kahneman gives another example of this phenomenon. He points to different economic predictions, like predicting a financial crisis, I have heard of too many people who knew well before it happened that the 2008 financial crisis was inevitable. This sentence contains a highly objectionable word which should be removed from our vocabulary in discussion of major events. The word is, of course, knew. So the key point that Daniel Kahneman is making is this. Those experts did not know in advance that the crisis would happen. For all that we know, they could have just made a coin flip. It's only when we look retrospectively at the past, only after the crisis happened, we have filtered out those experts who made the correct predictions. And that is the difference. To his credit, Johann Clement, after failing to predict the World Cup winner of 2026, said, "I ran out of luck." He acknowledged the fact that his model wasn't accurate or unfollowable, but there was a lot of randomness involved in it. So what is the lesson? The fact that someone predicted 3 winners in a row is much weaker evidence than it may seem. Why? Because we have only looked at those predictions and at that person only after the predictions were proved to be true. Nobody asked other people about their predictions for this World Cup. For example, I predicted all the winners of the World Cups and nobody wants to talk with me about it. Maybe because I got all of them wrong. But here's the point. We only look at the winners. And this is where the bias comes from. Professor Clement, maybe he is a genius. Maybe he was lucky. Or maybe it was a mixture of both. The key point is, we don't really know. And this lesson is very important in science and in life. For example, machine learning has the same problem if done badly. Imagine a researcher who tries 10,000 different models, 10,000 different hyperparameters or feature sets, and then reports, "My model has a 99.9% accuracy on the validation set." The validation set is now no longer a validation set. They effectively search until they found a winner. This is called overfitting to validation set or benchmark leakage. What about economy and investing money? Suppose you have 1 million investors, but they all randomly predict whether the stock goes up or down. On average, after one day, you will have 500,000 those who guessed right. If you repeat the procedure, you will have on average 250,000, half of that still got both days right. After 20 days, on average, you will have one person who got all the days correctly. That person may seem like a genius. In fact, it's just another instance of selection bias. Okay, so that might have sounded complicated, but what is the lesson for us? Well, whenever we hear about some expert who can make excellent predictions, we should always ask ourselves this question. Has this person really been tested, or whether we have just chosen one out of many with the hindsight knowledge of what happened? Being aware of this statistical illusion will help you and me make better decisions when it comes to life, investment, and even sports. In the meantime, enjoy the rest of the World Cup, and please write me in the comments below, who do you think will win?